Okay, and welcome to this video on transformations. This is actually a continuation of the previous transformations video that already exists on the Reigate Maths channel on YouTube. And essentially what's happened is in this particular video, what we're doing is we're looking at transformations with regards to reciprocals and how that they sort of play out in that respect. Okay. So what I thought I'd do, one thing that I've understood when doing these sorts of videos, when I'm using my tab, the sort of the drawing tool is not as good as I'd like it to be. So I'm going to have to use Desmos to try and do this the best possible way. So what we've got here, the previous page has already been completed in the previous video, and the key facets are all given here in terms of the language around transformations, reflection, translation, stretches, etc. So we're going to go straight into question 3, which involves us to do sketch the following graphs. Now, I particularly made these questions so it does in stages. So let's look at the first one, 2 over x plus 2. I'm going to be using Desmos here, which I believe will give a better experience for you in terms of visualization. So 2 over x has the normal, it looks like a normal reciprocal graph, okay? It's not really much of a difference from 1 over x. If I was to draw that on top, you see 2 over x is a bit more out from the x and y axes than 1 over x. But anyway, for the purpose of this question, we're doing with 2 over x. Now, when you're looking at this question properly, though, we have to realize that it's not just 2 over x, it's plus 2. And if you recognize the transformations from up above, when you add a number outside of a function or an equation, when you add a number to it, you are translating it in the y-axis by that number, okay, by vector 0, a. So if you sort of imagine f of x as being 2 over x, and I add 2 to it, then that whole graph should come up by 1. Okay, so I'm going to write this as f of x. This is my function, f of x equals 2 over x. And now what I'm going to do is I'm going to do f of x plus 2. Okay, and what you'll see here is that the original 2 over x graph has come up by 2. Okay, it's been translated up by 2. So I have done part A. Okay, that blue graph is what we need to have. Okay, so I'll write it out here, 2 over x plus 2. Okay. However, obviously, as a sketch, we do need to understand, what are the asymptotes, what are the x and y-intercepts if they exist any. So if I look back at 2 over x here, this is the original 2 over x graph, we can clearly see that its asymptotes were the x-axis, which is y equals 0, yeah, and the y-axis, which is given by the equation x equals 0. We know those asymptotes existed. However, when you translate the graph 2 over x up by 2 to get what we have now, those asymptotes, out of those two, one of them will shift up as well, and that will be the horizontal asymptote here, x equals 0. So originally that was for 2 over x, but because the 2 over x graph has gone up by 2, that will now, oops, sorry, not x equals 0, y equals 0. That will now come up by 2 as well. Okay, so that is now the new asymptote for this graph, and you need to have that in your sketch. Okay, so you need to have 2 over x plus 2, this blue curve. You then need to have the asymptote y equals 2 and x equals 0, the y-axis. I can also see an x-intercept here, minus 1, 0. Okay, how do they get that x-intercept? Well, as with most things in maths with graphs, to get the x-intercept, what you do is you make y equal to 0 and you solve. So 2 over x plus 2 equals 0. You get 2 over x equals minus 2, and you get x equals 2 over minus 2, which obviously gives you minus 1. Okay, so that explains the x asymptote there of minus 1, the x-intercept there of minus 1, 0, which you need to also have on your sketch. So that is now part A all completed. The blue curve 2 over x plus 2, the asymptote y equals 2 and x equals 0, and the x coordinate minus 1, 0. Now, if we look at part B, we've got 2 over x minus 1. Now, if we think about 2 over x again, that's our function. That's our original function. Now, if you look at 2 over x minus 1, if I put that x minus 1 around in brackets, because that's what you normally substitute x values into, then we can make an equivalence with f of x minus 1. In the bracket with the x, we're subtracting 1, which means that we can have that equivalence with this particular transformation, which is a translation in the x given by this vector minus a0. So what I'm expecting to see here, let's go back over this again. Here's 2 over x. What I'm expecting to see is if it's fx minus 1, I'm expecting to see the translation of the graph to the right by plus 1. Okay, so 2 over x minus 1, which is correct. Okay, you can see that red graph there as the correct version. Okay, so if I get rid of the 2 over x, just for now, there it is. That is your graph, 2 over x minus 1. However, there's clearly going to be some change in asymptotes. So let's go back to 2 over x. Remember what the asymptotes were. The asymptotes were x equals 0, y equals 0. Okay. However, because this 2 over x has been shifted to the right by plus 1, okay, then this vertical asymptote, which was x equals 0, is now no longer going to be the case. The new asymptote will be x equals 1. So this graph will have these new asymptotes, x equals 1, y equals 0. We also have a point of intersection here. So because the curve has gone to the right, or sorry, translated to the right by plus 1, there's been an intersection with the curve below the x-axis with the y-axis, 0, minus 2. Again, how do they get that y-intercept? How do you get y-intercepts generally? You substitute in x equals 0. So if you put in x equals 0, you get 2 over minus 1, which is minus 2. Okay? So there are no x-intercepts. If you were to try and get the x-intercepts while making y equals to 0, it wouldn't solve. So there you are. Okay, so that's part B done. Now, if you look at part B very carefully, yeah, we've done that. We know what the graph looks like. It cuts through at 0, minus 2. It's got an asymptote here, x equals 1, y equals 0. But if we then look at part C, we've got very much a similar type of graph. We've got 2 over x minus 1, but now we're adding 3 to it. And again, if I'm adding a number to the outside of a function, we then have to go back to this. We've got another translation in the x of 0a, or in this case, because I'm adding 3 to the outside of it, it's 0, 3. So this whole graph, 2 over x plus minus 1, is going to go up by 3. Okay. Now, because it goes up by 3, what changes are we going to get? Well, the vertical asymptote x equals 1 stays there, but because the graph has been translated up by 3, the horizontal asymptote will no longer be y equals 0, it'll be y equals 3. So on your sketch in part C, you need to have that graph with, going with the asymptotes x equals 1, y equals 3. Okay. Now we clearly have points of intersection. Okay, we've got 0, 1, which is the y-intercept, and we've got a third 0, which is the x-intercept. And you can find that out exactly by doing separate calculations, putting x equals 0 and putting y equals 0, and then solving them individually to get that. So there you have the final sketch of 3c, which is 2 over x minus 1 plus 3. Okay. Right. If I then scroll down and question 4, we've got more graphs, and these are reciprocal graphs with the x squared in the denominator. So I'm going to get rid of all this stuff here. Okay. And Stacey. And I'm going to just start with the first one. So I've got 1 over x squared plus 2. So let's start off with 1 over x squared. You should be able to recall this from a previous video. That is the graph of 1 over x squared. Now, if I'm adding 2 to it, to the outside of the function, again, I'll have to go back over my notes. I'm adding outside the function, translation 0a. So I'm going to shift this whole graph up by 2. There it is. Now, clearly, we're going to have some asymptotes. Let's get rid of the +2 for a second. The asymptotes that existed here were x equals 0. It didn't touch that. Sorry, it didn't exist there, and y equals 0. It doesn't touch that either. But because I'm adding 2 now, the x equals 0 asymptote stays, but the y equals 0 has to come up as well. So it's no longer going to touch the line y equals 2. That's the new asymptote. So that there is the final graph, 1 over x squared plus 2. And as if you look at this carefully, there are no intercepts with x or y. Okay, now we come up to this one, y equals 4 minus x all squared. So if I just do this first of all, 1 over 4 minus x all squared. What do we have here? We have this graph. Let's try and build this up in stages. Why does the graph look like this? Okay, so first of all, what we've got going on here is it'll be really important for us to find out where does this graph not exist. So what I look at is the denominator. Yeah, and I think to myself, what number, if I substitute into denominator, would not give me a y value? So if I look at that denominator, 4 minus x squared, I know that if I put in 4 for x, I'd have y equals 1 over 0 squared, which doesn't exist. So we know, therefore, that the x value of 4 is an asymptote. Okay, for this particular graph, the x value of 4 is the asymptote. It does not exist around there. Now, because of the nature of one, this square reciprocal, okay, we can use our previous knowledge. We know that the nature of the graph will look like this either side of x equals 4. And obviously, the other asymptote is y equals 0. Okay, and you can discover this. You can substitute in different values of x and try and do it that way. Okay. You can try and put in x equals 6, x equals 5, and you'll notice that as we increase the values of x, the values of y decrease, and the same on the left-hand side. Okay, so that is the shape. Final one that we've got on this video, y equals 5 plus 1 over 4 minus x squared. Well, hold on, we've already seen this aspect here. We've already seen 1 over 4 minus x squared already, and we're just adding 5 to it. And as we've seen in the previous examples, if I'm adding 5 or adding a number, that is going to translate the graph upwards. Okay. However, once you translate the graph upwards, the asymptotes also come up. So there you go. Right, and that is the final graph on the transformations page, and these are slightly trickier than the first page of transformations in your workbook. Okay, and well worth having a go at. There are some practice questions here, and I think as you go through the course, you will look at these transformations and they will steadily increase in difficulty, especially when it comes to trig. And that's the end of the video, and finish.